Emacs pioneered programming modes. Back in those days, there was only C mode for the C language. As languages proliferated, an effort was made to generalize the parsing engine upon which major modes relied. The engine is known by its acronym, PPSS, which is short for Parse Partial S-Expression State. The word partial refers to its incremental action, that is, it only scans code lines in the immediate vicinity of the cursor. And the word S-expression refers to the engines originating from Emacs's Lisp mode. You can imagine shoehorning a Lisp-centric parser to other languages would cause some friction, and you would be right. In his 20% time, a clever youngster, we'll call him Mr. Brunsfeld, wrote a parser generator like GNU Bison or AT&T Yak, with the key distinction that it produced a runtime that updated its parse tree on the fly. As you can see from the table, it does, quite literally, everything PPSS does. And because it was written by one competent person in one go, Tree Sitter represents a far more tractable and coherent story than the Byzantine but nonetheless impressive for its time PPSS mechanism, cobbled and patched together over 20 years by a revolving cast of characters. Tree Sitter is a no-fuss, drop-in replacement for syntax highlighting. Unfortunately, Tree Sitter cannot immediately replace PPSS for the other two syntactic features, motion over syntactic groupings, and indentation. Let's first demonstrate how to build commercial Emacs with Tree Sitter enabled, and then show how seamlessly syntax highlighting can be rerouted to Tree Sitter. We'll clone Tree Sitter, and we'll build it. It took, I don't know, maybe 10 to 15 minutes. I mean, it does take a while because it needs to run through all the grammars and produce their corresponding dynamic modules. And you'll see, all these calls that Tree Sitter generate on these grammars. I mean, it's doing real work. Okay, I issued another time-lapse forward. So during the interim, all I did was follow the instructions in the README to build a Tree Sitter enabled Emacs. And well, it's all built now. And one thing I wanted to point out was the performance of Tree Sitter syntax highlighting versus the extant mechanism known as just-in-time locking or JIT lock fontification. And if you cat the Tree Sitter tests log, one of the tests actually performs a speed comparison. And for a particularly large C module, Tree Sitter syntax highlighting took 1/3 of a second, whereas the JIT lock fontification took almost 2 orders of magnitude more, which doesn't really tell you how JIT lock actually performs, because JIT lock performs much better than that because it only fontifies that section of the buffer that you see. It sort of does a lazy fontification. And so my point is that only the most discerning of users could probably tell whether Tree Sitter syntax highlighting was any faster than JIT lock highlighting. I'll demonstrate syntax highlighting in action, not that it's any different than what you're used to. I'll use -Q here just to prove that I'm not pulling a fast one. The main switch to turn it on is font lock support mode. That's a custom variable. And I'm going to set it to Tree Sitter lock mode. The default value for that custom is JIT lock mode. But the way Tree Sitter lock mode works is if you enter a major mode and there's a Tree Sitter grammar for it, it will employ Tree Sitter syntax highlighting. And if there's no grammar for that particular language, it'll fall back to JIT lock mode. We can try a JavaScript file. I know that's really popular with you youngsters out there. We can add a list of strings and numbers. We can add a comment. Okay, not very interesting. Revert those changes. We could try a Python file. Print hello. A comment. Set print by 300. Okay, that's all the colorizing we need to see. Getting back to the features that we're not highlighting, motion and indentation, what about PPSS needs manual replacing? Well, PPSS is 3 things. A syntax table, which is the lexical scanning or YY-lex piece, parse partial S-expression, which is the YY-parse piece, and sandwiched in between is this hackfest called syntax propertized function, which is tailored for each major mode. Recall that PPSS was extended from Lisp mode, so if your language is Lisp-like, your syntax propertized function should be minimal. Otherwise, all the necessary regex hacks required to get your major mode working go into your bespoke syntax propertized function. So take Ruby mode, for instance. First, all the references to font lock, we already know that Tree Sitter has syntax highlighting buttoned up. So all these font lock considerations could go away. recall the three parts of PPSS, the first part being the lexical scanner in the form of a syntax table. Well, here it is for Ruby mode. And again, TreeSitter has its own grammar and its own idea of what Ruby looks like, so this could go away. There's the YY parse piece, which, at least for Ruby mode, is highly irregular. Ruby mode has its own version of parse partial S expression called Ruby parse partial, and you can see in the comment it says, why can't we just use the normal way of doing things? Please explain. And this is, again, is just exemplary, or rather emblematic of sort of the ad hoc nature of syntactic parsing in Emacs. And recall the third component of PPSS, the syntax properties function, which contains all the regex hacks to get the major mode working. Here are all the special rules that the authors of Ruby mode had to inject into their major mode to get syntactic parsing working well enough. And presumably, or rather hopefully, TreeSitter would not need these special rules. Okay, but it's not all fun and games. We would actually have to write some code to get a TreeSitter compliant major mode. So we talked about motion functions. Beginning of defun function is one of them. This is currently regular expression based. I'm looking at Ruby defun beginning regular expression here, and this would need to be rewritten to take advantage of TreeSitter's syntax tree. Similarly, there's end of defun function. There's things like Ruby forward S expression. Again, these are all regular expression based. They don't, under TreeSitter, they wouldn't need to be. There's also Ruby backward S expression. Okay. Oh, and then finally, there's the beast of indentation. And the indent line function is set to Ruby indent line, which is a helper for Ruby calculate indent, which is something of a monster. It's highly non-trivial. It's a highly non-trivial calculation of how to indent, and it is full of regular expressions such as this one. Yeah, well, you get the idea. regexp, opt, pretty crazy. Hanging re, what? Okay. Anyway,